I'm Bruce Fouke from the University of Illinois. Can you imagine if you got hungry that all you had to do would be to walk outside, put your arms out, and let the sun's rays hit your skin and provide you with food? Well, that would solve a lot of world problems. We're not there yet, but actually corals have approached their lifestyle of getting food from oceans in a very similar way. After the Permian-Triassic meteor impact, one very successful strategy that was developed in evolutionary biology on this planet is that some organisms invaded other organisms. In other words, the cells of some organisms moved inside the tissue structure and the host of other organisms. One of the best examples of this is when plant-like organisms called zooxanthellae invaded the tissues of corals. Now, when this happened, they remained plant-like zooxanthellae, but the actual physical cell moved into the outer surface of the coral tissue itself. So when we look at these corals in a histological cross-section, shine transmitted light through them to look at the ultrastructure of the tissue itself, we can see these small round cells called zooxanthellae that are happily dwelling within the tissues of the coral, which is an animal. Therefore, we have a relationship that's very close. Both organisms get something out of it called symbiosis. And in the end, the morphology of the coral will shift and change so it helps the algal-like dinoflagellate actually be successful. And that's the reason that corals have this polyp shape and resemble at some level plants themselves. Sharing and getting along with people and actually doing things collectively is a very critically important aspect of surviving. We often think of survival as being the person with the biggest gun and the biggest truck and the strongest person, and that's not really how evolutionary biology works. It's really collective cooperation. And the coral cooperation with these algae has set a benchmark in evolutionary biology for how to successfully evolve and maintain a healthy lifestyle within environments that can be somewhat difficult. When zooxanthellae invaded the tissues of corals, they established a relationship that was good both for the zooxanthellae and for the coral itself. We call that a symbiotic relationship, where both organisms get something very powerful and very positive out of that interaction. So the symbiosis for the coral in relationship to the zooxanthellae is that the coral first of all, gets an additional food source. It can eat some of the sugars that are produced by the zooxanthellae, but it actually can eat some of the zooxanthellae as well. Another thing that the coral gets from the zooxanthellae is the product of their photosynthetic reactions produces oxygen. So as an animal, the coral needs to use oxygen to respire. What does the zooxanthellae plant-like organism get out of it? They have the ability to have a safe place to live. They invade the tissues of the coral, and the coral provides a substrate where the algae-like zooxanthellae can live. The other thing that the coral provides for the zooxanthellae is the CO2 that they respire. Since the zooxanthellae is a plant, they can photosynthesize, and therefore they combine CO2 with sunlight to produce the sugars and other materials within their cells, as well as oxygen. So that drives the symbiotic relationship. Now, corals are remarkable because utilizing and leveraging upon this symbiosis, they actually have 4 different means by which they can eat. The first one is that they can extend their tentacles out into the water and feed from particles that are floating in the water. Another end member of that is that there is dissolved organic matter that's available in seawater, and they can actually just absorb the dissolved organic matter into their tissues. That'd be like us sticking our arm into a bathtub that was full of dissolved soup and be able to absorb the soup up through our arm. Another strategy they can use is they can eat the sugars that are produced by the zooxanthellae, or they can eat the zooxanthellae themselves. And the fourth one is that corals are able to produce immense volumes of mucus. They produce so much mucus that it sloughs off the skeleton and will float through the water column. Now, if things get really tough for the corals, they have the ability to eat their own mucus. Therefore, they produce the mucus as a protective layer for the environment, but then again, if the environment it gets tough and they run out of food, they can actually reconsume some of that organic matter that's trapped up in the mucus. In fact, corals make so much mucus that there are parrotfish. They have a large parrot-shaped jaw, and they're upwards of half a meter in size. And the parrotfish, one of the ways they make a living is they go around and they suck the mucus off the top of a coral and store it in their stomach. And then at night, to protect themselves, they vomit the mucus out, and they engulf their entire body within a basketball-sized bale of mucus. So if you're diving on the seafloor at night, it's not uncommon to see these weird large ball-like shapes that have a fish-like structure in the middle of them, and that's simply coral mucus that's being borrowed by the fish to protect them as they sleep during the night.